Welcome back, students. This is the Q&A session 22 from the playlist of Motion in a Plane. The topic is the calculation of the maximum speed of a body which is moving down in this inclined rough plane. So, based on this topic, I have selected one question which was asked in the IIT mains examination in 2013. So, the question here is a body starts from rest on an inclined plane of 45 degrees. So, this is the figure which I have already drawn in order to save the time. So, this is the inclined plane. The angle of inclination is 45 degree. Mu is equal to 0.3x. Mu is the coefficient of friction. So, the coefficient of friction between this body and this inclined plane is equal to 0.3x, where x is the distance traveled down the plane in meters. So, the body will have maximum speed when x is equal to. So, there are four options here, and we have to find the correct one. Here g is equal to 10 meter per second square. So here the body is starting from the topmost point A and it is coming down this inclined plane. Now when it is coming down in this inclined plane, it will be subjected to the weight component. It will be subjected to a force equal to mg sine 45, which is acting parallel to the inclined plane, and this is the component of the weight mg. This is the weight is acting vertically downward. So I have resolved this weight into two components. The one component is parallel to the inclined plane, which is equal to mg sine 45, and the other one is perpendicular to the inclined plane. So here mg sine 45 is acting in the downward direction. Now this is a rough plane, so the force of friction will be acting in the upward direction because the force of friction opposes the relative motion. So we in this case we will be first of all finding the net acceleration of this body when it is moving down. So the net acceleration, for calculating the net acceleration, we will be finding first of all we will find the net force acting on this body. Now since the body is moving in the downward direction, therefore the mg sine 45 should be greater than the force of friction, which I am denoting here as small m. So now the force of friction is equal to mu into n, where n is the normal reaction. So here the normal reaction is equal to mg cos 45. So this will be equal to mu mg cos 45. So the net force on the body will be equal to mg sine 45 minus mu mg cos 45. So from here we can say that the net acceleration of this body will be equal to, now the net for this force, which is basically equal to m into the net acceleration. So from here this m and m will get cancelled on both the sides of the equation. So the net acceleration will be equal to g sine 45 minus mu g cos 45. Now we also know that v square is equal to u square plus 2a s. This is the equation of motion for constant acceleration. So here if I apply this equation in this question, then v square will be equal to 2ax. So the body will have the maximum speed when the rate of change of this velocity with respect to x is equal to 0. That is, if I differentiate this with respect to x, then I will be getting 2v dv upon dx, and this will be equal to 2a. Or simply we can say that dv upon dx will be equal to a upon v. So when the rate of change of velocity with respect to x is 0, then we can say that the velocity has attained the maximum speed. So here the value of a is already done. The value of the net acceleration is now known to us, and so we can find this dv upon dx will be equal to g sine 45 minus, now mu is equal to 0.3x g cos 45 divided by v. Now here v is equal to root 2ax. So it implies that for maximum speed, dv upon ds will be equal to 0. We can say that g sine 45 minus 0.3x g cos 45, this should be equal to 0. So from here we can simply say that sine 45 minus 0.3x cos 45, this should be equal to 0. So on sine 45 is equal to 1 upon root 2 minus 0.3 upon root 2 x, because cos 45 is also equal to 1 upon root 2, and this is equal to 0. So from here I'm getting the this value as that x is equal to 10 upon 3, or it will be equal to 3.33 meters. So the correct option is D, that is 3.33 meters. So thank you very much for joining this session. In the next session I will be coming up with a different type of a question, and the question will be based on a different concept. So till then, have a nice day. Bye.